In this lecture, we are going to talk about how to reconfigure replicated state machines. We would like sometimes to increase the replication degree of replicated state machine so that, for example, to have 5 instead of 3 replicas. And we need to do changes quite often when either some of the machines fail or we would like to upgrade the software. And this is what we are going to talk about now. We are going now to motivate reconfiguration in a replicated state machine. As we know, a replicated state machine runs a set of processes, and for a sequence consensus to work, a majority of these processes has to be alive. Otherwise, the system will stall. So we cannot tolerate less than half of the processes failing. So one more process failing and the replicated state machine is unavailable. So we need a way to replace a faulty process. It is not only that, we need a way to update our software or to reconfigure our system depending on the demands of this system and where we want to put the different processes. They might want to change the configuration of processes so that some will be in one data center, others in another data center. But as you know, it is impossible to know if a process is faulty or slow in an asynchronous system. So we must be able to replace any process. And this is called reconfiguration or dynamic reconfiguration of replicated state machines. When we consider reconfiguration of a replicated state machine, we have to distinguish between policy and mechanism. Policy means when we need to reconfigure our state machine, and a mechanism is actually concerned of how we do the reconfiguration. There are many different ways to do this. So for example, external agent can decide when to reconfigure, and this is part of the policy. This external agent could be an autonomous management system or a human-operated management system. So this is both are possible. So the agent chooses new configuration. For example, if we have a system where we have 3 processes, P1, P2, and P3, that is one configuration, then we can create a new configuration where we remove P3 and we add a new process, P4. This is, for example, could happen if we just suspect that P3 is not operating or it is slowly operating. So we want to change that process. But in general, the set of processes in the new configuration could be a completely new set of processes. So it means that the old configuration and the new configuration are disjoint. In fact, this happens quite often when we want to upgrade our software on all machines. So we are really running new software. So in that case, old configuration and new configuration are disjoint. There are many other reasons to reconfigure systems, but these are the main reasons: failure and software upgrade or versioning of a system. Often, a single suspected process is replaced. So this is what is in the normal operation. You suspect a process, so you want to remove this process and replace it by something else. The process might be alive, but it doesn't matter. To be sure, we just replace the process, as we just shown here, when P4 replaced P3. So in the rest of this lecture, we are only going to be concerned with the mechanism of reconfiguration of replicated state machine. And the policy will depend on the use case and the application scenario. So we leave it open as much as possible. A configuration consists of a set of replicas. So in the first configuration, we have replicas R01, R02, and R03. And a reconfiguration means moving from this set of replicas to another set of replicas. In this case, we move to these replicas here. An important concept in reconfiguration is that, for example, this replica here and this replica here is actually running by the same process. So replicas could be thought of as instances of the same process. So a process might have multiple replicas, replica in configuration C0, replica in configuration C1, and replica in configuration C2. So that's what we say. process may act as multiple replicas. So you can think of replicas here as if these are concurrent actors and a process might be running multiple of these. So a process might be running this replica in configuration 0, this replica in configuration 1, and this replica in configuration 2. And in fact, what we talked about earlier, when we talked about sequence Paxos or Raft, we were talking about these types of replicas. And if the sequence consensus is leader-based, like leader-based sequence Paxos or Raft, then each configuration has its own election algorithm. So the election algorithm will run on these replicas in configuration C0, will run on these replicas in configuration C1, and so on. So here is what we are saying. We are saying process P1 is running these replicas, and the process, as we said, might act as multiple replicas in different configuration, as we said here. So a replicated state machine executes in a configuration until a reconfiguration occurs. In this case, it moves to the next configuration. And processes that move to the new configuration from a previous one does these asynchronously. We are an asynchronous system, so processes can move from one configuration to the next one, but these processes are independent and they can move at different time. Once a majority of processes have moved or entered a new configuration, then we say that this configuration is active. And in fact, we say that the replica of that configuration now is a running replica, and the previous one is a stopped replica. So, of course, this happens because processes run at different speeds. We are assuming an asynchronous system. The first configuration is C0. As usual now, it will start with the empty sequence accepted at round 0. It runs normally in this configuration. It means if a sequence is issued or a sequence is extended at a certain round n, then V is an extension of all sequences chosen at round n or at the previous rounds. So this is, again, this is normal. We have seen this all the time.